We're continuing on the topic trigonometry, and in today's lesson we want to find the sides of triangles, the sides and angles of triangles. But these triangles, they are not right angle triangles. So in our previous videos we found the lengths and the angles used in trigonometric ratios when the triangles used are right angles triangles. But when we're not using right angle triangles, or when we don't have a right angle triangle, we use two rules, the sine rule and the cosine rule. So in this lesson, we will look to see when the sine rule is used and how we apply it. So the sine rule says, when we find in a sine, A over sine A is equal to B over sine B equal to C over sine C. So A, the common letters, they represent the sides of the triangle, the length of the sides of the triangle. The capital letters represent the angles. So sine rule is saying, if I have a triangle and I divide the side by the sine of the angle opposite, it will be equal to another side divided by the angle divided by sine of the angle opposite it. So when we find the side, what I would suggest is put the sides at the top. When we find the angles, put the angles at the top, so it will make it easier for us to calculate, to transpose when we have to do so. So when given a triangle, and notice that the side, the common letter, is opposite the angle. So when we say A, that's the side, and the capital A is the angle opposite that side. When we say C, it is the side, and capital C is the angle opposite that side. B is the side, capital B represents the angle opposite the side B. So when we're finding angles, we put sine A over A is equal to sine B over B, which is equal to sine C over C. Now, when do we use the sine rule? When do we use the sine rule? Now, the sine rule is used in two cases. The first case, when we have two angles and a side. When we have two angles and a side. Like in this case, we have a given angle here, a given angle here, and a side. And we want to find the side opposite this angle. And that is another thing we need to point out when we're using sine rule. If we want to find a side, we must know the angle opposite that side. If it is we want to find an angle, we must know the side opposite that angle. So here two angles are given, and the side, we have an angle and a side opposite that angle. And we are given another angle here, and we need the side, we have to find the side opposite of the angle. So this is one case where two sides and an angle are given. Or we could have a side, an angle, a side, and another angle. Angle, side, angle. Alright? So we have here a given side and a given angle. We have a given angle and we need a side opposite it. So this is the case where when we're given two angles and a side, to find an unknown side, this is one way we can use the sine rule. Another way we can use the sine rule is when we're given two sides and an angle. Two sides and an angle. So this side is given, and this angle is given. And we need to find this angle x. So two sides, we have a side opposite the angle, and we need the angle opposite this side. So when we're doing sine rule, you must ensure that you have one side and an angle opposite that side. And if we were to find a side we need the angle opposite. So when you're working it, you must ensure those things are there, or those requirements are met in order for us to use sine rule. So the sine rule says A over sine A is equal to B over sine B is equal to C over sine C. Right? Or if we find the angles, we use the reciprocal. Sine A over A is equal to sine B over B, which is equal to sine C over C. And we use the sine rule when two angles on a given side are given, or right, two angles on a given side are given, or two sides and one angle. So in those two cases, we use the sine rule. In our next class, we will see some way or how to use the sine rule to calculate the length and the angle. In our last class, we did when sine rules are used, when the sine rule is used. So in this class, we want to find the side and the angle using our sine rule formula. Notice we said when we're finding a side, it's easier when we put the sides at the top, right? Make the sides the numerator. So we have A over sine A is equal to B over sine B, which is equal to C over sine C. Now, when we are solving, it is not necessarily for us to know A, B, and C or have the entire formula. What we need is just two of them, any two of them. So here we have one side and an angle, one side and an angle. So 11 is the side over sine 104. So ensure the side that we use, the denominator is the angle opposite that side, and the side that we need, which is x, and the angle opposite over sine 64. Now, our next step, what we want to do, remember we're finding the value for x. So we will transpose our formula to make x the subject of the formula. So what we do is take sine 64 across. Know that sine 64 here is dividing. So when it comes over, it will multiply. We will have to multiply. So now we will have 11 times sine 64 over sine 104 is equal to x. Equal to the value of x. So I hope you have your calculators, and remember in our last class we said ensure your calculator is in the degree function and not radians. So ensure it's in the degree function and we can work. So we now have 11 times sine 64. 11 times sine 64, and then that we divided by sine 104, which will give us 10.19 cm is equal to x. So the angle, the side x is equal to 10.19 cm to 2 decimal places. 10.19 cm. Now we will come to our next problem where we have to find the angle. And notice, remember what I said, when we need to find the angle, put the sign of the angle as the numerator and the side as the denominator. So here we have, let's start with what is given. Let's get a side and an angle. We have a side and the angle opposite is that side. So sine 53 over 7 is equal to sine y, which we need, over 5. Sine y over 5. So again, since we want y, we will transpose our formula. Bring the 5. 5 is divided, so when it comes over, it will multiply. So 5 times sine 53 over 7 is equal to sine y. Alright, so take your calculators and take your time and work that out. 5 times sine 53. 5 times sine 53 divided by 7 gives us 0.57 to 2 decimal places. Alright, now what we can do, or how to find y, we now have to find the inverse, sine inverse of that answer. Sine inverse of 0.57 is equal to y. So sine inverse 0.57 gives us approximately 34.75 degrees, the angle at y. Now, so here we have the angle at y will be approximately 34.75 degrees. Note, I want us to just keep in mind some things. That the largest angle is opposite to the largest side. Right? So if my answer was more than 11, if this answer at 64 was more than 11, I know something would have been wrong there. Now these are just some tips to help you that when you get your answer, you can check and see, you know what, this answer should be right. At least one way to know my answer is right is that the answer I have here, the side opposite 64, the angle 64 is less than the side opposite 104, since this angle is smaller than that angle. Now that doesn't say your answer is definitely right, but it helps us to have an idea that, you know what, it is somewhere, or it's on the path to being right. So we know this answer is right because we made a calculation. But what we do, if ever this answer we got was more than 11, that answer would have been wrong. So that is just a way to help you to recognize if something is going wrong with the calculations. Again here, notice that the angle at y is less than the angle 53, because the side opposite 53 is more than the side opposite y. Alright, if we had gotten an answer that was more than 53, something would have been wrong, since this side is smaller than the side that is given. So those are some tips we can look for to, or when we are checking back our answer. So in our next class, we will start, or we will look at the cosine rule. The cosine rule.